Section 6.4 is rational exponents. Our goal is to use the structure of an expression to rewrite it. On page 450, we have if a to the x power equals the fourth root of a cubed, then by definition, a to the x times a to the x times a to the x times a to the x equals a cubed. By adding exponents, a to the power of 4x equals a cubed. Then 4x equals 3. So x is 3 over 4. This suggests an alternative notation for radical expressions in which, for example, the fourth root of a cubed is equal to a to the 3 over 4th power. You can write a radical expression in an equivalent form using a fractional rational exponent instead of a radical sign. In general, the nth power of x is equal to x to the 1 over nth power for any positive integer n. Like the radical form, the exponent form indicates the principal root. So the square root of 36 is the same as 36 to the 1/2 power. Cube root of 64 is equal to 64 to the 1/3 power. Fourth root of 16 is equal to 16 to the 1/4 power. Example 1 says, what is the simplified form of the expression? For part A, we have 216 to the 1/3 power. The first thing we can do is take that 1/3 power and rewrite that as a radical. Since we have a 3 on the denominator, it's going to be a cube root. And then inside we would just have 216 to the first power, which is 216. Next, I would break 216 down into a prime factorization, or if you know another way to rewrite 216 right away, you're welcome to do so. 216 can become 2 times 108. 108 is 2 times 54. 54 is 9 times 6. 9 is 3 times 3, and 6 is 2 times 3. So that leaves us with 2 times 2 times 2 times 3 times 3 times 3. You don't have to write it out this way. You could have written just 2 cubed times 3 cubed, or you could have realized that we had 2 times 3 cubed, or 6 cubed. The cube root of 6 cubed is just 6. For part B, we have 7 to the 1/2 power times 7 to the 1/2 power. Again, we're going to rewrite these as radicals. Since it's 1/2, it is going to be a radical with an index of 2 or a square root. So we have square root of 7 times, again, square root of 7. Well, the square root of 7 times the square root of 7 is just the square root of 49, which is 7. For part C, we have 5 to the 1/4 power times 125 to the 1/4 power. We again can start by rewriting these as radicals. Since we have 1 over 4, we're going to have a radical with an index of 4, so the fourth root of 5 and the fourth root of 125. 5 is prime, but 125 is not. If you want to do a factor tree for 125, you get 5 times 25. 25 is 5 times 5. So when we have 5 times 125 in the fourth root, we can rewrite it as 5 times 5 times 5 times 5, or 5 to the 4th power. Now we have a fourth root and a 4th power. That's going to become just 5. We were allowed to multiply these two together like this because they were both fourth roots. Here's the work for part A, and then we have the work for part B. I do want to point out this little bubble here. It says you can also solve this problem by adding the exponents. So we have 7 to the 1/2 power times 7 to the 1/2 power. If you remember the rules of exponents, we have the same base. They're both 7. So we can add the exponents when you're multiplying, which would give us 7 to the 1/2 times 1/2 power, or 7 to the first power, which is just 7. If you don't remember these exponent rules, you can just rewrite it as a radical and work through it. Then we have the work for part C. Now I would like you to try number 1. Simplify each expression. -3 to the 1/3 power times -3 to the 1/3 power times -3 to the 1/3 power.